Assalamu alaikum dear students. In this video we will talk about alkenes in detail. So let's get started. First of all is the basic introduction. Alkenes are unsaturated hydrocarbons which consist of carbon to carbon double covalent bonds. What is meant by term unsaturated hydrocarbons? Unsaturated means that they consist of carbon to carbon double covalent bond. At least one double covalent bond is present in all alkenes. Hydrocarbon means that these are the compounds made up of carbon and hydrogen atoms only. The functional group for alkenes is carbon to carbon double bond, which is represented as two lines between the two carbon atoms with the extension bonds. These extension bonds shows that these carbon atoms are attached with the other atoms in order to complete their valence shell. The general formula for alkenes is CnH2n, where n represents the number of carbon atoms in a compound. Now, homologous series of alkenes. Like all other organic compounds, alkenes also form a homologous series of compounds. In this table, we will discuss the first 10 members of the alkenes homologous series, their names and their molecular formula. The first member of the alkenes homologous series is ethene, not methane. As for the formation of carbon to carbon double covalent bond, minimum 2 carbon atoms are required. So, methane does not exist. The first member of the alkenes homologous series is ethene. Eth is the prefix used for 2 carbon atoms and all the alkenes names end with ene. So, ethene is the first member of the alkenes homologous series. Its molecular formula will be derived by using the general formula, that is CnH2n. What will be its molecular formula? N will be taken as 2 here and hydrogen will be 2 into 2 makes 4. So, its molecular formula will be C2H4. The next member is with 3 carbon atoms and the prefix used for 3 carbon atom is prop. The name will be propene. What will be its molecular formula? Carbon will be 3 and hydrogens will be 2 into 3 makes 6. C3H6. For 4 carbon atom, but is used as the prefix and its name will be butene. Its molecular formula will be C4H8. For 5 carbon atom, pent is used. The name will be pentene and its molecular formula will be C5 and hydrogens will be 2 into 5 makes 10. C5H10. For 6 carbon atom, hex is used and its name will be hexene. The molecular formula will be C6. H will be 2 into 6 makes 12. For 7 carbon atoms, name will be heptene and its molecular formula will be C7. H will be 2 into 7 makes 14. For 8 carbon atom, oct is used. Name will be octene and its molecular formula will be C8 and hydrogens will be 2 into 8 makes 16. C8H16. For 9 carbon atoms, non is used and its name will be nonene. Molecular formula will be C9H18. For 10 carbon atoms, dec is used. The name will be decene and its molecular formula will be C10H20. Now, you will see in this series that between the successive member, there is a difference of CH2 group. Between two successive members, there is a difference of CH2 group. This means that there is a mass difference of 14 units between the two members of the homologous series. For example, between propene and butene, the difference of mass will be 14 units as carbon is 12 and for 2 hydrogen atoms 2 is used, mass will be of 14 units. So, as all the alkenes have same functional group, so they show similar chemical properties, while their mass changes as we go down the homologous series, so there will be a gradual change in their physical properties. Now, in this table, we will draw the displayed formula or the structural formula for the first 5 members of the alkenes homologous series. The first member is ethene. What does the molecular formula of a compound tells? It tells us about the actual number of atoms present in a compound. Actual number of atoms present in the molecule of a compound. The displayed formula or the full structural formula tells us about the bonds and the arrangement of atoms in a compound. Arrangement of atoms. Whereas structural formula tells us about the arrangement of atoms in a compound. So, for ethene, the molecular formula is C2H4. We will draw its displayed formula. There must be a double covalent bond in the chain of carbon atoms. So, as only 2 carbon atoms, so double bond will be present in between these 2 carbon atoms, and the other bonds are made with the hydrogen atoms. So, what will be its structural formula? How these atoms are arranged. First carbon atoms that I have marked it with a star. It is attached with 2 hydrogen atoms. Then the second carbon atom, it is also attached with 2 hydrogen atoms. So its structural formula will be CH2CH2. Next member is propene. Its molecular formula is C3H6. So first I will draw a chain with 3 carbon atoms. There must be a double bond in the chain, and the rest of the bonds will be made with the hydrogen atoms. There must be 4 bonds for every carbon atom. So I will start making bonds from the right side. I have bold this carbon atom. So there is a double bond with it, so it will only make bond with 2 hydrogen atoms, and its 4 bonds are completed. The central atom, it has already 3 bonds, so it will make only one single bond with the 1 hydrogen atoms, and the last one, it has only 1 bond with the carbon atom, so it will make 3 bonds with the 3 hydrogen atoms. There must be 6 hydrogen atoms in total in the propene. Count the hydrogen atoms: 1, 2, 3, 4, 5 and 6. Now we will draw its structural formula, and it will be written like this. I will start from the left side. I will number the carbon atom that is present on the left side as carbon number 1. This carbon number 1 is attached with 3 hydrogen atoms, so CH3 will be written. The second carbon atom is attached with only 1 hydrogen atom, CH, and it is the third carbon atom which is attached with the 2 hydrogen atoms, so it will be written as CH2 here. CH3, CH, CH2 will be the structural formula for propene. Next member is butene. Its molecular formula is C4H8. For its structural formula, I will first make the chain of 4 carbon atom with a double covalent bond in it. I will make the double covalent bond in between any carbon atoms, but while writing its name, we will have to mention the position of the double bond as well. Always number the carbon atoms from the side at which functional group is present nearer to it. So as the functional group is present in between the 2 carbons that are present on the right hand side, so I will start numbering from here. This is carbon 1 and this is carbon 2. So the name of butene will be split and its name will become but1ene. As the double bond is present between the carbon number 1 and 2, so the name of this alkene will be but1ene. 1 shows the position of functional group in the compound. It is very important to mention the position of functional group in an organic compound. Now I will complete its displayed formula. I have made a chain of 4 carbon atoms with a double bond, or the rest of the bonds will be satisfied by the hydrogen atoms. 1, 2, 2 hydrogen atoms will be present. With the second carbon, 3 bonds are already present, so only 1 hydrogen atom will be present with it. For the third carbon, 2 bonds are present, so it will make the other 2 bonds with the 2 hydrogen atoms. Fourth and the last carbon atom, it will make bonds with the 3 hydrogen atoms. Now I will draw the structural formula. So I will start making the structural formula from the left side, starting from the fourth carbon atom. Fourth carbon atom is attached with 3 hydrogen atoms. Third carbon atom is attached with 2 hydrogen atoms. Second carbon is attached with 1 hydrogen, and the first carbon is attached with 2 hydrogen atoms. So this is the structural formula for but1ene. Now we will discuss physical properties in detail. So first property is the physical state. First three members of the alkenes homologous series are gases at room temperature and pressure. This means that ethene, propene and butene, they exist as gases at room temperature and pressure. From pentene onwards till alkanes with 15 carbon atoms, they exist as liquids, and from alkanes with 16 carbon atoms onwards they are solids. This means that as we go down the homologous series, with the increase in the number of carbon atoms, the forces of attraction are getting stronger, and the state changes from gases to liquids and liquids to solids. Next property is the solubility. Solubility follows the principle of like dissolves like. Like dissolves like, which means that polar substances tend to dissolve in the polar solvents, and non-polar substances, they are dissolved in the non-polar solvents. As organic compounds, they are all covalent in nature, so they are insoluble in polar solvent like water, but they are soluble in organic solvents like benzene, toluene, carbon tetrachloride. So the other physical properties follows a trend with the chain length. Chain length refers to the number of carbon atoms in a compound. So the physical properties like melting points, density and viscosity. Viscosity is the fluid's resistance to flow. Heavier fluids, they are difficult to flow, whereas the fluids which are lighter in mass, they are very runny. They flow with the greater ease. So the trend for these three physical properties is that they increases with the increase in the number of carbon atoms as we go down the homologous series. The reason for this increase is with the increase in the number of carbon atoms, or with the increase in the molecular size, the forces of attraction between the molecules, it increases. Next physical properties are the flammability and combustibility and the volatility. So these physical properties, they decreases with the increase in the number of carbon atoms in a compound. This means that their trend decreases as we go down the homologous series, because as the number of percentage of carbon increases in the compound, it becomes difficult for the hydrocarbon to burn. It burns with more smoky or sootier flame, and in the flame unburned hydrocarbon or unburned carbon particles are present. And volatility also decreases, because with the increase in the number of carbon atoms in the compound, with the increase in the molecular size, the forces of attraction increases, and it becomes difficult for the molecules to evaporate. This is all about the physical properties. Now, manufacturing of alkenes on industrial scale. Alkenes are obtained by the cracking of crude oil. So cracking is done industrially to produce alkenes. As the name shows, cracking means to crack down or to break down. Its definition is it is the breakdown of a longer chain alkanes into smaller alkanes and alkenes. The conditions for the cracking are absence of air, otherwise the combustion will take place or they burn. The temperature of 400 to 600 degrees Celsius is required, or catalyst is used are aluminium oxide and silicon 4 oxide. Broken porous pot is also used in labs as porous pots are also made up of silicon 4 oxide. The general equation for the cracking is longer chain alkane may be broken down into smaller alkane with alkene, or they may be broken down into smaller alkene with the evolution of hydrogen gas. So there are two options for the product. When a longer chain alkane is cracked down, there are two options. First option is that a smaller alkane is formed with alkene, or second option is smaller alkene is formed with the evolution of hydrogen gas. Now we will do some examples. First example is we will crack down the octadecane, which consists of 18 carbon atoms, into alkane and alkene. So for this it depends in the question how many carbon atoms they are asked you to take in alkane or to take in alkene. I am taking 9 carbons in alkane and 9 carbons in alkene. So alkane plus alkene will be the product. So for alkane I am taking 9 carbon atoms, which means that nonane will be formed. And for alkene 9 carbon atoms means nonene will be formed. The molecular formula for nonane is C9H20 and for nonane it is C9H18. So the number of carbon and hydrogen atoms are also equal on both sides of the equation, so equation is balanced here. There is another option for the products, that the mixture of alkenes may be formed with the hydrogen gas. For example, if I will take as alkene here as C9H18 with the hydrogen gas. Now I have to balance this equation. There must be 18 carbon atoms on both sides. So I multiply nonene with the 2. The carbon atoms now will become 18 and hydrogen atoms they are 36. So 36 plus 2 hydrogen atoms from hydrogen, it will make total hydrogen atoms as 18 here, 38 here. The next example is, there is a question, hexadecane cracked down to produce ethene with a gas that produces pop in flame. Construct the balanced equation for the reaction. So hexadecane is C16H34. It cracks down to produce ethene C2H4 with a gas that produces pops in flame. So this is the confirmatory test for hydrogen gas. It produces pops in flame, so hydrogen gas is produced. Now I need to balance this equation. There are only 2 carbon atoms in ethene. So in order to make it 16, I will multiply it with 8. Now there are 16 carbon atoms and 8 into 4, 32 hydrogen atoms. And from the 2 hydrogen atoms from hydrogen gas, the number of hydrogen atoms become 34 and carbon they are 16. So this means this equation is now balanced. Now what is the importance of cracking? Cracking is used to produce petrol in order to meet the demand of fuel with the supply. As you know that the need for the petrol is greater than the need for diesel oil or lubricating oil, because they are made up of longer chain alkanes. So in industries, through cracking, these longer chain alkane molecules are converted in petrol in order to fulfill its demand with the supply. The next is to produce short chain alkenes, mainly ethene. Why ethene is mainly produced during cracking process? Because it is used in the production of ethanol. It is used as a reactant here, as a raw material here. It produces ethanol, and it is also used as raw material in the manufacturing of plastics. The last is cracking is used to produce hydrogen gas. Hydrogen gas is used as a raw material in the Haber's process for the industrial scale manufacturing of ammonia gas. So these are the importance of cracking, why it is done largely on industrial scale. This is all about today's lesson. I hope you will find this lesson helpful in learning the basic concepts of alkene, and keep learning and keep growing. Allah Hafiz.